All right, ladies and gentlemen, welcome back to the wonderful world of physics here at VAHS. It stopped snowing outside, and today we're looking at kinetic and potential energy. This is our last topic for physics this year, and one that I think is fun. We've always kind of looked at it. We experience it on a daily basis. It's one that tends to get a little bit confusing at times, and I'm going to hopefully try to clarify the confusion with it and be able to show you how to be able to look at it from a different perspective. So let's kind of jump into this. Now, kinetic energy is the energy of an object which it possesses due to its motion. That's the important part there, due to its motion. And all that is saying then, due to its motion, there we go. It is defined as the work needed to accelerate a body of a given mass from its rest to its stated velocity. So we tend to think of this as energy in motion. Energy in motion. So it's the active part of it. And kinetic energy then uses stored potential energy. And we'll talk a little bit about that in just a second. But as we turn potential energy into kinetic energy, it's now energy that is at rest, and it now gets turned into motion, or turned into energy through the process of its motion. Now, we can use that or see that as an example. You can hold a ball above your head and you can drop it. The ball above your head holds potential to do something, to do work. And there is energy involved in that. There's a force times the distance, which is again energy in joules. And the potential then is once you release your hand, the potential which is stored gets turned into kinetic energy, or energy in motion. And then the ball can fall to the ground, and we've now turned potential into kinetic. And we'll talk a little bit about that at the end here of what all of that is saying in this motion. Now, potential energy is then the opposite of that. Energy is stored in a body or in a system. It's due to its position in a field. Okay? And so we tend to think of this then as energy at rest. So this one is energy at rest. And so again, we can talk a little about the different types of potential energy that we've got. You pull a rubber band back and you hold it there. You have now put potential energy into the system. So when you hold it there, we call that elastic potential energy. So again, we can have a couple of different types then to this. We can have, where'd my thing go here? Sorry about that. Here we go. We can have two different types of potential. We can have one called elastic. Oh my gosh, my spelling is horrible today. Elastic potential energy, and the other one is gravitational. Is gravitational stored energy. Now, an elastic energy, this is a stretch. This is where you stretch or pull something back like a rubber band or a spring. You could actually pull a string together or push it together. So anything that has a stretching property, springs, rubber bands, I'm trying to think of something else that would be an elastic potential, would all be then you're storing energy into it, and it's not moving yet. So as soon as you let go of the rubber band, the potential turns into kinetic energy, of energy in motion. Same thing if when you let go of the spring, you're turning then your potential energy into kinetic energy. So that's one form of it. Gravitational then potential energy is looking at then as you hold something up, again the ball example, you hold a ball above your head, you are then putting gravitational potential energy into the system. And as you then let go of the ball then turns from potential into kinetic energy as gravity then is pulling the ball down then. So those are the two different types of potential energy, elastic and gravitational. Now we can take a look at then our equations for these then. And this is one of the things that we kind of need to make sure that we kind of get into this whole process, is that kinetic energy is, here's our equation, 1/2 mass velocity squared. And then potential energy is just mass times gravity times height. So again, if you're holding an object above your head, it's the mass times the gravity times the height at which you're looking at. Then kinetic energy, because the energy of speed or in motion, we then need to take the velocity into consideration, how fast it is moving then. So with that, we've got then a couple of different equations then which we can put into our system here. Here's our kinetic energy, 1/2 mass velocity squared, and our potential energy, mass times gravity times height. We can then use to separate those out by a couple of different ways then. So we've got mass is going to be equal to kinetic energy divided by 1/2 the velocity squared. And you've also got mass being the potential energy divided by gravity times height. We can then separate out gravity and height as well. And the equation then for velocity, don't forget about the equation for velocity, which is a really important one. So we've got velocity equals the square root of the kinetic energy divided by 1/2 the mass. So what you need to do in that order of operations is take the kinetic energy divided by 1/2 the mass, hit equals, and then square root that number. And that would be your then velocity of the object. So the other thing to kind of think about in this whole thing, which I think is probably the most important part of this whole concept of potential and kinetic energy, is this, is that, let's kind of get that to stop there, there we go. So what we've got here is, if we think about this, that we've got the PE at the top is going to be the same thing as the KE at the bottom. And so that's going to be an important concept, so that when we think about if you transfer the potential energy into kinetic energy, that you can kind of think of it as a system that would go from 0 to 100. That at the top, if we said if we had PE and we had KE and we had PE and we have KE, so if you just look at the system there, okay, the potential energy at the top would be 100%. The kinetic energy at the top would be equal to 0 because it's not in motion. It's not doing anything, it's standing at rest. Once the object then lets go, what you'll see is the potential energy then goes from 100 to 0. So at the bottom, once it's hit, there is no more potential energy. It has stopped. And what happens is the kinetic energy then goes to 100. So you're transferring all of the potential then into the kinetic. So that's a really important concept that I want to make sure that you understand and get, is the potential energy at the top of the system is equal to the kinetic energy at the bottom of the same system. And that's one that you're going to need to be using when we start to get to some of the problems then, is this whole concept of it. Now, I happen to find a really nice little kind of animation as far as looking at then these kind of very same things. So if we take a look at, here's the fall, and it's that same thing, that as we look at the potential and the kinetic, so the potential at the top is equal to the kinetic energy at the bottom in a closed system. Now on that trampoline, right, we're conserving that, and that's where that whole idea of momentum now comes into play, is that we're conserving the energy in that system, in a frictionless system there. But if you looked at the ball there on the left, that once the ball fell, it's now turned into heat. So basically what we've done is we've used the energy to do work. And that outcome then produces some type of heat. Generally friction is what we're looking at then. Another way that we can kind of look at that same type of concept is here in the swing. So we now have, you can kind of see potential energy in blue, kinetic energy in green. So that is when the swing is not in motion, you've got 100% potential. And again, that potential gets turned into kinetic energy. So the PE at the top, right there, is equal to the KE at the bottom, right there. So again, we're converting all the potential into kinetic energy. So we're converting stored energy into active energy. And that's really kind of all that we're looking at in that example then. So we can kind of see the same thing there. The spring oscillates, so now there's our elastic potential energy that gets stored into the spring, and you can kind of see that as you release the elasticity, the stored potential in there, and has the ability to do something and do some work then. Great. So now let's go back to this then, and let's take a look at some of the problems then. And what you'll kind of find with these things is hopefully kind of some straightforward things. So just take a look at number 1. Calculate the kinetic energy of the ball. Here's a mass, here's a velocity. So we've got kinetic energy equals 1/2 mass velocity squared. So what we end up with that is that we've got 0.5 times 0.7 times 40 squared. So do the 40 squared first in your order of operations and then multiply everything out second after that, and you'll end up with 560 joules. Now, another one to kind of take a look at to kind of help to differentiate this, and so hopefully you can kind of see this, is in number 3 then. A large chunk of ice with a mass of 10 kilograms falls from a roof 8 meters above the ground. Determine the kinetic energy. So again, we would probably go kinetic energy equals 1/2 mass velocity squared. Now the problem here, right, is we've got a mass here, but the thing is, this is a distance, and we don't have a velocity. So okay, we'll go to then the velocity equation, which would be then distance divided by time. Wonderful. Again, we have a distance, but we don't have a time. So we can't use this equation to solve for kinetic energy. Now that's for that whole idea that the PE at the top equals the KE at the bottom. And so what we can also do then is solve for kinetic energy by taking the mass times gravity times height equation of potential energy. And so now we can plug this in. We've got 10 times 9.8 times 8, which then equals 784 joules. So don't get concerned about not always having the right things. You got to be able to think through, what is this information telling me and what information do I have available to it then. Okay? So enjoy potential and kinetic energy. If you have any questions, please make sure that you're seeing me in class or you're looking at the answer board on the side. Otherwise, take care and we'll see you soon.